In this session, we're going to look at the enhancements that have been made in Power Builder and in PowerServer 2022 that help improve the performance of PowerServer applications. So first, a legal disclaimer. And let's look at our agenda. So what we're going to talk about is we're going to talk about two new objects that have been added, PowerServer label and PowerServer result. We're going to talk about the change from newtonsoft.json to system.text.json for handling the serialization, deserialization of JSON in the web services. We're going to look at the option to do .NET Standard 6.0 rather than .NET Core 3.1, I'm sorry, as the framework we're going to use. And we're going to look at the option to use HTTP 2.0 rather than HTTP 1.1. So first, a little bit about me. I assume at this point most everybody knows who I am. And a little bit about the company I work for. Okay, so first thing we're going to talk about is the new PowerServer label object. And what this does is it allows us to take multiple data window requests, and instead of having them done as separate API calls, we're going to batch them up into a single API call. So there's some properties on the PowerServer label object. Merge enabled max merge calls. We don't necessarily use, just information. Main thing we might want to look at is the results object, results array, which is an array of this PowerServer result object, which is the other new object. The methods on the PowerServer label object are start merge and end merge. Those are the two main things we're going to use. On the PowerServer result, there's three properties, and it's basically the same properties you would see on SQL CA. SQL code, SQL DB code, and SQL error text. The idea being that even though this is a merged call, if there are, let's say, 3 data windows that are being merged together into this one API call, the results will have 3 PowerServer results, one for each of the data window calls. And then you can check the SQL codes, SQL DB code, and SQL error text of the individual data window retrieves, even though they've been merged into a single API call. So here's my sample code. In this particular sample, I'm going to grab the CPU before and after so we can see what the performance improvement is between merging and not merging. This sample assumes that we've got some PowerBuilder code that we might be deploying as PowerServer, but also as client server or Power Client, where it wouldn't necessarily even have PowerServer label as an option. So I'm checking first of all to see if it's a PowerServer app. And then if it is a PowerServer app, then I'm going to check the merge checkbox. And if it's checked, then I will merge these 3 data window retrieves into a single API call. So you call the start merge, you do all the you indicate all the data windows that are going to be retrieved as part of this single API call. And then when you do the end merge, that is when the API call is made. If that's not checked, we're just going to do the retrieves individually, and that's going to allow us to do the before and after comparison as far as performance. Then this is an example of using the PowerServer result. So assuming it's a PowerServer app, which is the only time this would ever come into play, and that I've actually checked my merge button in this particular application, I'm going to loop through the PowerServer label results array and check each one individually and see if there were an error on any one of them. And if there was an error on any of them, I would display the result, the error code for those data windows that failed. What I've done here, you can tell by the prefix, perhaps, is I've created a PowerServer label object in the as a global variable in this particular application. So let's go ahead and take a look at the demo. So here we're going to look at how we use the PowerServer label object. I've got 3 data windows, and you notice there is a merge checkbox up there. Here in the code, I'm going to create a PowerServer label. I'm going to connect all 3 data windows to SQL CA. And I'm going to check to see if it's a PowerServer app, because it's only in a PowerServer app we can use the PowerServer label. So if it is PowerServer app, and if the merge checkbox is checked, I will do the start merge, retrieve the 3 data windows, and do an end merge. Otherwise, I would do the same thing as if it weren't a PowerServer app, which is just retrieve the 3 data windows. I'm also going to capture the CPU start and end so we can see how long it took and get the count of the rows returned by the data windows. And then finally down here, if it's a PowerServer app and the merge is checked, the PowerServer label object has a results array, which is the PowerServer result object. And I can loop through the PowerServer result objects and return an error code for each of the data window retrievals if there is some kind of an error. Okay, so let's take a look at this. I'm going to go ahead and run it in PowerServer, of course. Now what I've done here in these 3 retrieves is I've limited the result set to the first 100 rows. I'm sorry, 1,000 rows. And the idea is as your data sets get larger, the transfer of the data overwhelms the performance enhancement you get from combining the results, because it takes so long to retrieve the data. So this will tend to work better if you are doing a lot of smaller calls rather than large data set retrievals. But let's see what the difference is here. So 3,000 records, 1,000 per data window in 718 milliseconds. I turn on merge, do it again, and 469 milliseconds. So almost half the time is saved. And so get a 2 times performance increase by combining the 3 retrieves into a single call rather than making it 3 separate calls. And that's because of the overhead of doing the REST API call. But like I said, if you do start doing hundreds of thousands of rows returned, you won't see as much of a performance benefit, because the amount of data you're retrieving, that takes so long regardless of whether or not you're doing the merge, and so you won't see that much of an increase. But if you are doing a lot of small retrieves, that shows how the merge can really help out. Okay, the second area where the performance improvement has to do with replacing Newtonsoft.json with system.text.json. Now this actually occurred at the ASP.NET Core 3.1 layer. So this is something that happened not only for PowerServer, but for any ASP.NET Core application that is using more recent versions of ASP.NET Core. And so this particular link here is where I got these slides. This was actually looking at the improvements that are seen in standard ASP.NET Core applications. But you can see that there are dramatic improvements in both the serialization and the deserialization of data using the new library as opposed to the Newtonsoft library. Now, for this performance improvement, you don't need to make any changes in code. You just need to migrate to PowerServer 2022 because the changes are all handled internally within the framework. Next thing we're going to look at is the option that's been made available with PowerServer 2022 to use .NET 6.0 standard rather than .NET Core 3.1 as the framework that you deploy to. I couldn't find any sources that talked about what the performance differences between 3.1 and 6.0 directly were. What I did find is I kind of found a couple sources here indicated the performance difference between .NET Core 3.1 and .NET 5, and then the performance difference between .NET 5 and .NET 6. So you can see for .NET Core 3.1 and .NET 5, they were seeing a 20 to 105% increase in performance moving to .NET 5. And then from moving to .NET 5 to .NET 6, there was anywhere from a 5 to 45% increase in performance doing that switch in the framework layer. So theoretically here, by changing from .NET Core 3.1 to .NET 6, you could probably see anywhere from 25 to 150% improvement in speed of your application. Now, for this, we do need to make, it's not necessarily a code change. We just need to change the way we deploy in the PowerServer project. So you go to the PowerServer project, go to the .NET Server section, go to the Advanced tab, and there is a target framework selection. And the two options there are .NET Core 3.1 and then .NET 6.0. And so what you could do is just change over to .NET 6.0, redeploy your application, and you should see some performance improvement. The last thing we're going to look at is HTTP 2. And let's talk about HTTP 1.1 first. That standard was published in 1999, and in internet terms, that is dinosaur age. So HTTP 2 is like a long overdue overhaul of that standard. It was presented in 2014, proposed this as standard. In 2014, proposed this as standard in 2015, and published in May of 2015. 97% of current browsers support it. One thing from a security standpoint is that it is more secure than HTTP 1.1 because it does require that you use TLS 1.2 or higher. You can't use the older SSL versions with HTTP 2. Approximately 50% of websites currently support it. Just as some of this is just a matter of information. The method status codes and header fields are all the same as 1.1. The big difference, and this is where the performance improvement comes in, is that HTTP 2 uses binary format rather than a text format for the data. And so that in itself makes HTTP 2 much faster than HTTP 1.1. Some of these apply just to really web pages rather than an API. For instance, this next one is if your browser makes a call using HTTP 2 for a web page, and the server knows that web page references image files, the server could push the image files back to the client even before the client asks for them. So save some time there. It allows for header compression, and it allows the client to specify the prioritization of requests, which actually gets into this point I skipped over, which actually has an effect for API calls as well, is that HTTP 2 allows for multiplexing your requests. So it basically opens up the pipeline through which we can transmit the data. And that's where the client prioritization comes in, although that doesn't necessarily apply to API calls. But the idea that the client can send several requests, but it can indicate that certain requests have higher priority than others, and that the server needs to prioritize those over the other requests. There is, for the record, there is an HTTP 3 standard that was recently, as June of 2022, published. but that's going to be a while before it's really adopted, and it actually has some major changes over to. For instance, it publishes data using UDP rather than TCP. It may be a while before we see that being implemented. Anyway, that was a sidetrack. Let's look at the performance increase we get from HTTP2. So in this particular request, this is a fairly minor request, and we didn't actually see, because of everything else that's going on with getting the data, doing the SSL handshake, getting the data, all that. We didn't see an overall. Actually, it made HTTP2 looked a little slower here, but the important difference is right here in the speed of transmission. Oh, went too far. So what we're seeing here is that the speed of transmission for HTTP1, the data was sent at 18 kilobytes per second, and in HTTP2, the data was sent at 88 kilobytes per second. So that's about a 4.5 times increase in the speed of the transmission of the data because of the binary format that HTTP2 uses. Now, like the change to the JSON libraries, we really don't have to make any code changes here for you to take advantage of HTTP2. The big difference, the big requirement, is that you need to either host the service either in IIS 11.0 or later, or in ASP.NET Core 3.0 or later Kestrel server. At that point, the use of HTTP2 is the default method used, and you would actually have to go into something like the IIS manager and turn it off if you didn't want HTTP2. And that's all I had. So it's time for questions and answers.